Have you ever wondered what it means when the sky begins to whisper? Not with thunder, nor with storms, but with something quieter, something that seems to breathe between the stars. Somewhere beyond the gentle pull of our sun, a wanderer is passing through, a visitor from another corner of the galaxy. Astronomers have named it 3I Atlas, and in the cold December days of 2025, it will align almost perfectly with the Earth and the Sunday. Now that may sound like nothing more than geometry, but geometry, you see, is the handwriting of the universe. It draws connections across impossible distances. And when our world finds itself standing between a star and a traveler from beyond, one cannot help but ask, what story is being written there? Perhaps nothing will happen. Perhaps everything will. Or maybe, just maybe, the cosmos is sending us a quiet message, and the question is not whether we will receive it, but whether we are still capable of listening. 3I Atlas does not behave like the comets we know. It brightens too early, burns too strangely, as though it remembers something, a place it once called home, long before entering our sky. And there is something deeply human about that, isn't there? The longing to return, even when we know we never will. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map tonight? Let me know where you are in the world and what time it is where you are. It's always fascinating to see who's joining us from all around the world. So, let's continue. Because every story has a beginning, and this one begins with a lonely traveler entering the light of our Sunday. It began, as these things often do, with a faint glimmer, a whisper of motion on the edge of the known. Somewhere in the outer darkness, where the gravity of our sun fades into the deep pull of the galaxy, something appeared. At first, it was only a line of numbers on a computer screen, a faint track against the starfield, but behind those numbers was a traveler, ancient beyond comprehension, making its way toward the warmth of our star. Astronomers called it 3I Atlas, the third confirmed visitor from beyond our solar system. And though it was nothing more than a speck of light, it carried the weight of an entire story, a story written across interstellar time. You see, most comets belong to us, in a sense. They circle the sun in long, predictable loops, bound by its gravity. They fall inward, flare with brilliance as their ice turns to vapor, and then retreat again into the cold, awaiting another cycle. But 3I Atlas was different. Its path was not an ellipse, but an open curve, what scientists call a hyperbolic orbit. That meant it came from elsewhere, from the spaces between stars, and once it passed through, it would never return. It was a guest that would visit only once, never to be seen again. And there was something hauntingly beautiful about that. The thought that a fragment of another system, another sun, another time, was passing through our own, almost brushing against the gravity that holds us here. Its speed was astonishing, faster than any natural object native to our solar system. Even as it crossed the orbit of Jupiter, it was racing through space at tens of kilometers per second. To put that into perspective, it would take a modern spacecraft centuries to follow the same path. And yet, this tiny fragment, no larger than a mountain, had been crossing the void for perhaps millions of years. Each kilometer it traveled carried the memory of countless collisions, the scars of ancient light, and the silence of interstellar dust. I sometimes think of it as a message in a bottle, tossed into the cosmic ocean long before Earth had continents. And now, for a brief moment, it has washed up on our shore. But there was something else, something subtle that caught the attention of astronomers almost immediately. 3I Atlas began to brighten too early. Normally, a comet remains dark and inert until it nears the sun, when heat causes its frozen gases to sublimate and form a glowing coma. Yet, this visitor began to glow even before it had reached the orbit of Jupiter. It was as if it had woken up too soon, like a traveler stirring before dawn. That was strange, and in science, strangeness is where curiosity begins. Some suggested it was made of unusually volatile materials, ices that evaporate at lower temperatures. Others proposed it might contain internal fractures, pockets of trapped heat that released energy unevenly. And then there were those who wondered whether something more complex was at play, perhaps a mechanism of light scattering, or a surface shaped in ways we could not yet imagine. But no matter the explanation, the fact remained. 3I Atlas was alive with light in the farthest reaches of cold space, long before it should have been. When I think about it, I imagine it drifting there, silent and alone, illuminated by the faint sunlight that reaches those distances, a fragile spark against the backdrop of eternity. There is poetry in that, isn't there? To shine when no one is watching, to burn quietly, not for glory, but simply because that is what you are made to do. And perhaps that is what draws us to such stories. Every time a visitor like this arrives, humanity looks up again. Telescopes turn, data streams fill the servers, people gather on hillsides with binoculars, tracing faint trails in the sky. For a few moments, we all share the same sense of wonder, the realization that the universe is not a static picture, but a living dance of matter and motion. A comet is not just a rock, it is a messenger, carrying the story of its birthplace, a place we will never see. The first two visitors taught us this lesson well. The first, discovered in 2017, was called Oumuamua, which in Hawaiian means a messenger from afar arriving first. It was unlike anything we had seen, elongated, tumbling, with no visible coma, and yet accelerating slightly as if pushed by some invisible force. Then came Borisov, in 2019, a more conventional comet but still unmistakably interstellar, trailing a faint blue tail as it rushed past the Sunday. And now, this third traveler 3I Atlas has arrived, behaving differently once again. Almost as though each visitor carries its own personality, its own mysterious fingerprint of motion. When scientists plotted its orbit, they saw something peculiar. The path traced a gentle curve through the solar system, entering from the direction of the constellation Lyra, swinging near the Sun, and then outward again toward the constellation Hydra. Its perihelion, the closest point to the Sun, would come around the middle of December in the year 2025, just as the Earth would find itself nearly in line with it. Three bodies, the Sun, the Earth, and this distant visitor, briefly aligned across millions of kilometers of space. It is, of course, coincidence, a simple act of celestial geometry. And yet, when you think about it, even coincidence can carry a kind of quiet grandeur. Because what are alignments, after all, if not echoes of deeper harmonies? The planets themselves move in resonance, each orbit tracing a rhythm that repeats across eons. The moon aligns with the sun, and we call it an eclipse. The tides rise, the shadows lengthen, and the world grows still. In those moments, we sense how small we are, and yet how perfectly placed. So when a traveler from another star happens to join that alignment, it is hard not to wonder whether the universe is humming a note just beyond our hearing. And that, I suppose, is the heart of it. Every scientific discovery begins with a question, but not all questions are meant to be answered immediately. Some are invitations to look closer, to listen more carefully. 3I Atlas is one such invitation. It challenges our models of what a comet should be, how it should behave, how it should move. But beyond the equations and trajectories, it also invites something more personal, a reflection on impermanence, on passing through, on the beauty of things that visit and leave. For all our instruments and data, we must remember that science, at its core, is an act of curiosity. It is the human desire to understand, to connect dots across the unknown. When astronomers measure the orbit of a comet, they are also, in a way, measuring themselves their own capacity for wonder. Every number they write down is a small declaration that we are here, watching, listening, caring enough to know. Sometimes, late at night, I imagine what it would be like to stand outside, somewhere far from the city lights, and see that faint point of light in the sky, knowing that it has come from another sun, that it has wandered for ages through the dark, and now, for a few nights, it shares our sky. What would you feel in that moment? Awe? Loneliness? Perhaps both. Because when we look at an interstellar object, we are also looking at ourselves, at our own journey through space and time. The Earth, too, is a traveler, orbiting a star that drifts through the Milky Way. We are, all of us, visitors. And so, as December of 2025 draws near, astronomers continue to watch. They calculate, refine, and debate. They compare the new data to models, tracing the subtle flickers of light that betray the comet's changing behavior. Each observation adds another brushstroke to a portrait still incomplete. But there is one thing they all agree upon. This moment, this brief intersection between worlds, is precious. It is easy, in a world full of noise, to forget the sky. But when something like 3I Atlas appears, the silence of space becomes a kind of mirror, reflecting not just light, but thought. Perhaps that is the real significance of such visitors. They remind us that the universe is vast, yes, but also connected. That even in the coldest distances, there are bridges of gravity and light linking one world to another. And so, as the comet approaches the heart of the solar system, as its tail begins to unfurl and catch the sunlight, we watch not out of fear, but fascination. Because within that glow is a story written across unimaginable distances, and for a fleeting time, we get to read a few lines of it. And that leads us, naturally, to the next mystery: why this light, this strange and restless light, behaves in ways we cannot yet explain. Because when the laws of physics seem to bend ever so slightly, that is when wonder truly begins to take shape, and the universe, for just a moment, feels alive again. Light behaves according to laws we have come to trust. It bends around gravity, scatters through dust, and fades with distance. But with 3I Atlas, light seemed to have its own ideas. When astronomers pointed their instruments toward it, still far beyond the orbit of Jupiter, they noticed something peculiar. It was already shining. Not faintly, not tentatively, but vividly enough to defy the cold logic of distance. Out there, where sunlight is weak and frozen matter should sleep, it began to stir a ghost awakening in the dark. Normally, comets remain silent until they approach the Sunday. The warmth loosens their icy shells, freeing gases that expand and scatter sunlight, creating the luminous halo we call a coma. But 3I Atlas began to glow too early, as though some inner spark had reminded it of its purpose. It is tempting to think of this as a kind of memory, a buried instruction left by a forgotten star. Of course, the scientific mind resists such romance. It seeks mechanisms, pressure, composition, radiation. Still, there is something poetic about a fragment of ice, remembering to shine long before it feels the warmth of light. At first, researchers proposed simple explanations. Perhaps its surface contained volatile compounds, elements that sublimate at much lower temperatures than water ice, carbon monoxide, carbon dioxide, or ammonia. These materials could react even in the far reaches beyond Jupiter, releasing energy as they escaped. Others argued it might have internal fractures that trapped solar heat, slowly building pressure until small jets burst forth, scattering dust and reflecting light. Yet none of these hypotheses fully captured the persistence of its brightness. It was as if the comet had an internal rhythm, pulsing gently as it drew nearer, refusing to obey the usual rules. You see, in physics, we often describe light as obedient. It tells us where things are, how they move, how much energy they carry. But in this case, the light itself was the mystery. It was not merely a reflection of sunlight. Spectrographic readings revealed irregularities, wavelengths that did not correspond neatly to any known mixture of gases or dust. The intensity fluctuated, not in smooth, periodic waves, but in brief, uneven surges. A few observers even recorded faint polarization patterns, suggesting the light was being scattered by something more structured than random grains of dust. Something that, for a fleeting moment, organized itself against the void. When scientists encounter such behavior, they return to fundamentals, the physics of radiation. Every particle of light, every photon, carries a history of interaction with atoms, with fields, with time itself. The glow of 3I Atlas, strange as it was, still had to obey these same principles. And yet, the data whispered of irregularities that did not belong to simple chemistry. If the comet's brightness were due solely to outgassing the release of vaporized ice, then its light curve should follow a predictable pattern. But it didn't. It rose sharply, fell abruptly, then steadied again, almost as if controlled by some hidden metronome. Well, perhaps it was only coincidence. Or perhaps it was telling us that even the simplest processes, when carried out across interstellar distances, can become strange beyond measure. Imagine a fragment formed in another planetary system, under a different star, exposed to cosmic rays for millions of years. Its structure could have changed in ways our models have never accounted for: the layering of exotic ices, the rearrangement of atoms, the slow embedding of magnetic fields. When sunlight finally touches such a surface, the reaction might not be predictable. It could release bursts of energy, even light itself, in patterns we have never seen. There was another possibility too: the presence of internal heat. Some researchers speculated that cosmic rays or radioactive isotopes trapped within the comet's core might have generated slow, steady warmth over millennia. This heat, once enough pressure had built, could awaken the surface, creating jets even in the far reaches of space. But that explanation felt unsatisfying, like a story told to quiet a child before bed. The truth was, no one could say for certain why 3I Atlas was already shining. And yet, this is precisely what makes science so deeply human. We long for certainty, but the universe gives us wonder instead. When light behaves strangely, it is not an error, it is an invitation. It calls us to look deeper, to listen longer. What struck me most was the timing. The comet began to brighten just as it crossed into the outer regions of our solar system, where sunlight is faint but constant. The energy it received there was roughly 1/25th of what the Earth enjoys, and yet its response was disproportionate. It flared as though it had felt a sudden wave of recognition, as if, after ages of drifting through cold emptiness, it had finally seen the glow of a familiar star and thought, "Yes, there you are." It is a foolish thought, I know, to imagine emotion in a comet. But then again, perhaps all our metaphors for light are borrowed from emotion. We say things are bright when they inspire us. We speak of illumination when we understand something new. To shine is to reveal, and to reveal is to connect. In that sense, maybe 3I Atlas was not breaking the rules of physics at all. Perhaps it was simply expressing them in a language we had not yet learned to translate. As the weeks passed, more observatories joined in. Amateur astronomers, too, contributed their images, filling online archives with thousands of faint streaks of light. Some noticed how its coma appeared lopsided, as if a single jet was pushing harder than the rest. Others detected a slight flicker in brightness every few hours, the signature, perhaps, of a tumbling body spinning through space. The data hinted that the nucleus might be irregular, fractured, or hollowed out by ancient impacts. Each explanation added another layer to the story, but none completed it. The more we looked, the less we understood. And that, I suppose, is where humility returns. The universe has a way of reminding us that knowledge is not a possession, but a pursuit. We do not own these truths, we only chase their reflections. 3. Atlas was a mirror, in that sense not of glass, but of mystery. Still, there were patterns worth noting. The light it emitted seemed to prefer certain angles, certain geometries between the sun and Earth. At times, the intensity changed not because of the comet's own activity, but because of the way sunlight scattered off its halo. This hinted at complex interactions between dust particles and solar radiation, what physicists call radiation pressure. Even the smallest grains can be pushed by light, drifting outward to form a shimmering veil. If those grains are metallic or charged, they can align themselves along magnetic fields, polarizing the reflected light. In such moments, the glow of the comet becomes a living experiment in fiber, electromagnetism, a dance between photons and plasma. And that is where things grow even more intriguing. Some researchers began to notice slight discrepancies between the direction of its tail and the path it should have taken. In most comets, the tail points directly away from the sun, sculpted by the solar wind. But here, it twisted, as though responding to invisible currents. Was it merely turbulence in the solar wind? Or could it be that the comet's own electric field was interacting with the charged particles streaming from the sun? If so, then the brightness of 3I Atlas was not just a passive reflection, but an active dialogue, a conversation between light and magnetism, between matter and the invisible forces that govern it. In that idea lies something beautiful, the thought that light, in its infinite simplicity, might still surprise us. A comet brightens because it transforms. Ice becomes vapor, dust becomes light, motion becomes story. It is, in a way, a rehearsal for every transformation in the universe, from starbirth to human thought. And 3I Atlas, out there beyond the orbit of Mars, was performing its own quiet metamorphosis, unseen by most, yet deeply moving to those who chose to listen. Perhaps that is why its strange luminosity resonates with us. It mirrors our own hunger to awaken, to respond to the warmth of discovery, even when the night around us feels endless. To be human is to glow against the odds, to reach toward understanding, even when the light is faint. As the comet moves inward, closer to the sun, its behavior will change again. The brightness may surge, the jets may multiply, the tail may twist and lengthen until it paints the sky with threads of silver. And when that happens, when its light bends across our atmosphere and brushes the magnetic skin of Earth, the question will arise once more. What does this alignment truly mean? Because light, no matter how far it travels, always finds a way to reveal connection. And the geometry of that connection between a star, a planet, and a visitor from beyond is where the next chapter begins. Geometry, at first glance, seems like the language of certainty. Lines meet, angles form, and everything appears to fit within a framework of logic and precision. But in the vast theatre of the cosmos, geometry becomes something far more poetic, a choreography of chance and gravity, where the alignment of 3 wandering bodies can turn into a moment of quiet significance. And that is precisely what will unfold when the Earth, the Sun, and 3I Atlas find themselves almost perfectly arranged along a single invisible thread of space in the final days of December, in the year 2025. Now, alignments are not rare in astronomy. The planets line up, the moon crosses the path of the sun, shadows stretch and dissolve in perfect order. Yet there is something uniquely intimate about this one, because this time, one of the participants is not a familiar neighbor, not a planet or a moon, but a visitor from the deep, an interstellar fragment born under another sun. And the Earth, our Earth, will briefly stand in the middle, between the endless source of light and the one who reflects it. If you could step outside the solar system and look back, you would see something astonishingly simple. A narrow beam of geometry, stretching from the sun through our small blue world and continuing outward to a speck of frozen dust now blazing with energy. That line is not a road, not a connection in the way we imagine them, but it is a kind of dialogue. The sunlight that leaves the surface of the sun will reach the Earth after 8 minutes, and 3i Atlas after a few more hours. And for a brief moment, that light will unite all three in a cosmic alignment that is both ordinary and miraculous. To most people, it will pass unnoticed. There will be no change in the tides, no trembling of the ground. But in the language of physics, something subtle will happen. The Earth will find itself moving through the faint trace of material left behind by the comet's tail. That tail, made of gas and charged dust, stretches for millions of kilometers, forming a fragile bridge of particles flowing away from the sunday. The Earth will not collide with it in the dramatic sense. There will be no impact, no fiery display, but it will pass through the outer fringes of that luminous trail. And when it does, our planet's magnetic field will respond. The magnetosphere of Earth is an invisible shield, shaped like a teardrop, pushed and sculpted by the solar wind. It deflects charged particles, funnels them toward the poles, and gives us the auroras, those ethereal curtains of green and violet light. When a stream of solar particles meets this magnetic shell, they interact, releasing energy that dances across the upper atmosphere. Now imagine that, instead of the usual stream from the sun, there comes a faint infusion of material from beyond, particles once part of another star's debris, carried here by the comet's long journey. For a moment, the two systems, one familiar, one alien, will touch through the field lines of magnetism. This is not science fiction. It is physics, delicate and invisible, unfolding in the background of our everyday lives. And though we may never feel it directly, the Earth will respond, as it always does, to the cosmic weather around it. The alignment will be like a whisper, not a shout, a faint modulation in the current of solar wind, a subtle shift in the shape of our magnetic bubble. Satellites might record small fluctuations. Observatories might notice a flicker in radio frequencies. But to those who know how to listen, such changes are not noise, they are music. Because, well, the universe has always been musical in its patterns. The orbits of planets, the spin of electrons, the oscillation of stars all follow rhythms that can be measured and, if one dares, imagined as sound. If the cosmos were a symphony, then perhaps this moment in December would be a soft chord played between three distant notes: the sun, the Earth, and the comet, each vibrating in its own way, yet briefly in harmony. The ancients might have seen this as an omen. In their sky maps, alignments were moments of divine geometry, signs that heaven and earth were in conversation. Today, we no longer speak of omens, yet we cannot deny the feeling that arises when nature aligns so precisely. It is not superstition, but recognition, a quiet awe that we are part of something vast and patterned, something that existed long before our words for it. As the comet approaches its perihelion, its closest point to the sun, its tail will lengthen and bend. The solar radiation will push against it, creating two streams, one of dust and one of ionized gas. The dust tail, composed of microscopic grains, reflects sunlight directly. The ion tail, charged and sensitive, follows magnetic field lines that twist through the solar wind. Together, they form a structure of almost impossible fragility, threads of matter, thinner than smoke, stretching across millions of kilometers. When the Earth crosses the same region of space, its magnetic field may stir those threads, just slightly, enough to create ripples that travel down the length of the tail. Astronomers call these magnetic reconnections, brief moments when lines of force link and release energy. On a planetary scale, they generate auroras. On a cosmic scale, they are the heartbeat of plasma itself, the silent language through which the universe exchanges energy. And perhaps, on that day, somewhere high above the poles, faint curtains of light may ripple in unusual ways, patterns that differ from the familiar dances we know. What makes this thought so moving is that it does not rely on drama or disaster. It is not about collision or destruction. It is about alignment, the quiet resonance that happens when geometry becomes destiny. The comet will not strike the Earth, nor will it darken the skies. But it may, for a brief moment, leave an imprint on the invisible fabric that surrounds us. And perhaps that is the deeper message here. The universe does not always speak through cataclysms. More often, it whispers through balance, through the delicate way light curves around a planet, or the way a magnetic field trembles when touched by a breath of interstellar dust. These are not omens. They are invitations to pay attention. I sometimes imagine what it would look like from the comet's perspective. Out there, beyond the orbit of Mars, drifting toward the Sun, it would see the Earth as a small blue dot glowing against the blackness. It would watch the sunlight gleam off oceans, the thin haze of atmosphere wrapping the world in a soft halo. And as the alignment approached, that blue dot would move into position precisely along the line that joins the comet to the Sunday. The light from the star would pass by the Earth and reach the comet's icy surface, scattering and returning toward us. In that moment, the three bodies would share the same beam of light, a single conversation spanning millions of kilometers. Light, you see, is the oldest messenger. Every photon that strikes your eye tonight may have begun its journey before humanity even existed. When the light of the sun touches the surface of 3I Atlas, it carries with it the memory of our star's fusion, the signature of our place in the galaxy. And when it bounces back, some of it returns to us, encoded with the secrets of another world. This exchange, this dance of reflection, is the geometry of communication itself. The cosmos does not speak in words, but in alignments, in orbits, in the silent touch of light. It is humbling to realize how fragile these alignments are. A fraction of a degree, a small tug of gravity, and the moment would vanish. Yet here it is, prepared by nothing more than the patient unfolding of celestial mechanics. The sun burns, the earth turns, the comet glides, and every so often their motions intertwine just so. It reminds us that order and chaos are not enemies but partners, weaving patterns through the fabric of time. There is a quiet philosophical truth hidden in that idea. The same laws that govern the motion of galaxies also shape the fall of a raindrop. Geometry connects them. Every orbit is a story of attraction and resistance, of falling and being caught. The Earth's magnetic field, too, is an expression of geometry, an invisible sculpture carved by molten iron and cosmic wind. And when that geometry meets the path of a visitor from another world, we are witnessing more than coincidence. We are witnessing the rhythm of the universe revealing itself for a heartbeat. Somewhere, perhaps, a radio telescope will detect a faint disturbance, a flicker in the background noise. Somewhere else, a satellite will record a shift in the pattern of charged particles streaming around Earth. Most people will never hear about it, and that is all right. Because not every wonder demands an audience. Some are content to exist, quietly, like the alignment itself, perfect, brief, and then gone. And when it passes, when the comet begins to drift away again, the Earth will continue its orbit, the sun will burn as it always has, and the geometry will dissolve back into randomness. But those who watched closely will know that something extraordinary happened, not because the sky changed, but because for a moment we understood it a little more deeply. And that understanding, fragile as it is, leads us to the next question. Because not everything we have observed about this comet fits the equations we rely upon. Its brightness, its motion, even the way its tail bends, all seem to hint at forces we cannot fully explain. And when the laws of physics begin to blur at the edges, that is when curiosity becomes courage, and science begins to dream again. For all our confidence in the mathematics of motion, the cosmos has a quiet way of humbling us. The orbits of comets, the light of distant suns, the bending of dust and gas, all of it can be predicted with astonishing precision. Yet, every so often, something arrives that does not fit. Something like 3I Atlas, whose path through the solar system seems to whisper that not everything is obedient to gravity alone. At first, the calculations made perfect sense. Observatories across the world fed their data into the models maintained by the great institutions, NASA, ESA, and the countless private observatories that map the heavens each night. The early trajectory matched what one would expect from a comet pulled by the sun's gravity. Its speed, its arc, its approach all aligned with Newton's quiet equations. But then, as the weeks passed, the predictions began to slip. Not by much at first, just a few thousand kilometers here, a fraction of a degree there. Yet, in celestial terms, those tiny errors were enormous. Imagine throwing a pebble across a lake and predicting its landing spot within a single grain of sand. That is how precisely we can usually calculate these things. So when 3I Atlas began to drift from its predicted path, astronomers took notice. Some suggested errors in measurement. Others blamed unseen jets of gas, subtle bursts of vapor pushing against its body and nudging it off course. But even after accounting for that, the numbers still refused to settle. What puzzled the scientists even more was the way its brightness changed. Comets usually grow brighter as they near the sun, their tails lengthening in response to heat, but this one behaved erratically. Its light would surge, then fade, then surge again, as if responding not to distance but to something else entirely. One night, the coma surrounding it appeared dense and glowing. The next, thin and ragged. The tail itself shifted direction ever so slightly, pointing not straight away from the sun as physics would dictate, but at an odd angle as though pulled by an invisible thread. To explain this, researchers turned to a familiar mystery, one that had haunted astronomy since the discovery of another visitor from beyond Oumuamua. That object too had defied expectations. It showed no visible outgassing, no tail, and yet, as it left our solar system, it accelerated. Not much, but just enough to betray the laws we thought we understood. The term scientists used was non-gravitational acceleration, a sterile phrase for something profoundly unsettling. It meant that some unseen force, something other than gravity, was at work. With 3I Atlas, the same phrase began to appear in research papers again. Non-gravitational acceleration. It was as if the universe had placed a quiet footnote in our equations, a small reminder that even our best understanding remains incomplete. Of course, there were proposed causes asymmetric outgassing, where one side of the comet releases more vapor than the other, creating a gentle thrust. That explanation worked for many comets, but not neatly here. The energy required to produce such a steady shift was too great, the pattern too consistent, and the direction of movement did not align with the observed jets. Others suggested the possibility of plasma drag, an interaction between the comet's charged particles and the magnetic flow of the solar wind. This idea carried elegance. If the comet's surface contained metallic dust or ions, it could act like a small sail within the sun's magnetic field, catching its energy and subtly altering its path. Yet again, the data resisted simplicity. The force needed was too steady, too continuous, as though the comet were under a constant, deliberate influence, rather than a chaotic one. And then there were the whispers, the hesitant conversations that drift through the corners of science, the ones that begin with the words, "It is probably nothing," but some wondered if the object could contain a structure within, something dense or reflective, something that behaved not like rock or ice, but like metal. Not alien technology, not necessarily, perhaps a fragment of a long-dead planet, a core exposed to the vacuum and magnetized over millions of years. Yet even this remained speculation. The cosmos does not yield its secrets easily. What struck many observers was the direction of the tail. The tail of a comet should be a faithful servant to the sun, always pointing away from it, sculpted by the solar wind. But the tail of 3I Atlas seemed to bend unpredictably, at times curling slightly sideways, as though feeling the tug of a field not aligned with the sun's own. For weeks, instruments traced this motion. Some thought it might be the result of rotation, a complex spin causing uneven release of material. Others suspected electromagnetic interference, the delicate interplay of charged particles between comet and solar wind forming invisible ropes of plasma. The truth is, space is not empty. It is filled with invisible tides, streams of particles, fields of energy, ripples of magnetism. Every comet that passes through these forces becomes a kind of antenna, responding to them in subtle ways. But 3I Atlas seemed unusually responsive, as if finely tuned to the invisible rhythms of the heliosphere. Its motion felt almost too graceful, too deliberate. Of course, to think of deliberation is to trespass into philosophy. But that, I suppose, is part of the wonder. Science begins with measurement and ends, often, in awe. To look at this comet and see it ignore our models is not to lose faith in physics, but to be reminded that physics itself is not finished. We stand at the edge of understanding, like children tracing shapes in the sand while the tide of truth waits just beyond. I remember reading one astronomer's words in a quiet online forum late one night. He wrote, "Every time we fit a new parameter to explain 3I Atlas, the universe adds another unknown." It was not frustration, but admiration. Because that is the rhythm of discovery. The closer we get, the deeper the mystery becomes. When researchers at the European Space Agency compared data with NASA's Jet Propulsion Laboratory, they noticed something else. The spectral signature of the comet's coma, the light scattered from its dust and gases, changed over time in ways not consistent with temperature alone. Certain wavelengths would flare and vanish, as though specific compounds were being excited and then quenched in cycles. No known chemical process matched the timing. It was almost as if the comet was responding to fluctuating electromagnetic fields around it. This led to another line of thinking. Could 3I Atlas be interacting with the sun's magnetic environment more deeply than we had realized? The solar wind is not a uniform stream, but a turbulent sea of plasma. When a body passes through it, especially one with a conductive surface or magnetic remnant, eddies form. These can exert forces tiny, invisible hands that push and pull. If the comet carried even a faint magnetic memory from its home system, it might resonate differently within our sun's influence. The idea is both wild and beautiful, that a fragment born around another star could still remember the magnetic song of its origin. And perhaps, in some small way, that memory is what we are seeing the dance of two different cosmic histories touching for the first time. Our sun, singing in charged particles, the comet, humming back in the key of another world. Their resonance shaping light, motion, and mystery across the span of millions of kilometers. Still, among all these ideas, there lingers a deeper lesson. The failure of our models is not a failure of science, but its triumph. To find something that does not fit is to be reminded that knowledge is alive. It breathes, changes, questions itself. When a comet drifts from its expected path, it is not defying nature, it is revealing it. And so, 3I Atlas continues its journey inward, crossing the invisible borders of the solar system's domains. Each observation adds a new note to the symphony of confusion. The tail sways, the brightness flutters, the motion deviates ever so slightly from what gravity alone can command. And somewhere in the midst of all that data, hidden like a faint heartbeat in the noise, lies a truth we do not yet have the language to describe. Perhaps that is why scientists have begun to look beyond conventional explanations, beyond simple physics, into the liminal spaces where plasma, magnetism, and light converge. Because if we are to understand this visitor, we must be willing to accept that the universe is not a machine but a conversation that occasionally answers us in riddles. And in those riddles, as we shall see, there is room for imagination, and for 5 possible stories that might explain why this silent traveler has chosen to glow, to drift, and to defy us. Each one rooted in the same physics we know, yet reaching toward the edge of what we dare to believe. When mystery grows thick, science does what it always does: it builds stories. Not myths, but hypotheses, small and fragile bridges across the gulf between what we know and what we suspect. And 3, I-Atlas has inspired many such bridges. After months of observation, debate, and revision, 5 broad possibilities have emerged to explain its strange behavior, 5 ways the universe might be speaking, each beautiful in its own way. None are certain, all are plausible. Together, they form a map of curiosity, drawn across the silence of space. The first story begins with light itself a burst, a flare, a sudden release of energy that momentarily outshines reason. Some astronomers propose that what we are witnessing is not constant illumination, but pulses, bursts of electromagnetic radiation released as the comet's surface interacts with the solar wind. When the charged particles from the sun strike certain materials, they can trigger brief surges of electric discharge, like miniature lightning storms playing across an alien crust. These bursts could account for the unpredictable changes in brightness, the erratic glows that flicker and fade. It is not unlike a thundercloud, you see, only stretched across millions of kilometers. In Earth's sky, lightning is the language of imbalance energy seeking harmony. Perhaps, out there in the darkness, the same principle applies. The light of 3 I-Atlas could be the voice of equilibrium being restored, a brief dialogue between charge and void. In that sense, it would not be strange at all, but profoundly natural, a cosmic storm unfolding so slowly that we perceive it as mystery. And yet, the way it pulses, so measured, so rhythmic, has left some uneasy. Random processes rarely feel so deliberate. The second story drifts deeper into the invisible, into the realm of magnetism and plasma, where geometry and motion merge. There are those who believe the comet may have become caught in a resonance, a kind of magnetic echo. The solar wind carries magnetic fields that twist and fold as they travel. When a conductive body enters this region, its own weak field can align with those waves, setting up oscillations that grow stronger over time. Imagine 2 voices singing slightly out of tune until, at a certain pitch, they harmonize. Energy flows freely between them, amplifying both. If 3 I-Atlas is engaged in such a resonance, it would explain its strange path and persistent glow. Its tail would respond not simply to radiation pressure, but to invisible magnetic strings stretching from the sunday. These interactions could produce torque, gentle rotations, even accelerations, all without the need for jets or outgassing. The comet would become an instrument, playing the tune of the heliosphere. And we, watching from afar, would be hearing the faint music of plasma made visible as light. The third story takes us back to the more familiar language of matter, to heat, fracture, and release. It imagines the comet not as a solid block, but as a fragile assembly of frozen materials barely holding together after millions of years in deep space. Perhaps within its core lies a mixture of volatile ices, trapped pockets of gas, and brittle rock. As it nears the sun, those pockets could rupture, causing sudden outbursts, jets that flare briefly, pushing the comet and brightening its halo before subsiding again. This phenomenon, known among comet watchers as fragmentation, has been seen before, though rarely with such irregular rhythm. In this view, 3I Atlas is a survivor of cosmic violence. It carries the memory of collisions, of heat and cooling, of deep fractures that awaken under stress. Its light is the flicker of old wounds reopening. Yet, as tragic as that sounds, it is also a reminder of persistence. Even in breaking apart, the comet teaches us how fragile structures can still endure, how destruction and revelation are often the same thing. Perhaps each flare we see is the whisper of material not lost, but reborn gas returning to sunlight after aeons of darkness. The fourth story is the most provocative, though even those who propose it do so with caution and humility. It begins not with what the comet does, but with what it does not do. Its acceleration does not match any known pattern of natural outgassing. Its brightness sometimes increases without corresponding loss of mass. Its tail, under certain angles, reflects polarized light that seems structured, almost geometric. Could it be, some wonder, that 3I Atlas contains material not entirely natural? Now, to say such a thing is not to leap toward fantasy. It is simply to note that nature, too, builds structures that look designed. Crystals, for example, grow with precision. Ice forms lattices of astonishing regularity. What if, by coincidence or by the unique conditions of another star system, this comet contains minerals or metals that respond to light in organized patterns? Or, and this is the idea that lingers on the edge of daring, what if a fragment of something ancient, something built, became part of it long ago, trapped within its frozen shell? We know that stars form planets, that planets die, that civilizations, if they exist elsewhere, must eventually vanish. Their remnants, too, might wander. Not spaceships, not intact artifacts, but fragments, alloys, crystalline frameworks, microscopic debris. If such material were embedded in a comet and set adrift, it would behave differently under radiation. It would scatter light in unusual ways, and perhaps even produce subtle accelerations as solar energy interacted with it. It is not proof of anything beyond physics, but it is a poetic possibility that 3I Atlas might carry the ashes of another world. And then there is the fifth story, the simplest, yet the most elusive. It suggests that we are witnessing an optical illusion born of rarity, a phenomenon of reflection that our instruments are not yet calibrated to understand. The comet's surface, shaped by time and heat, might consist of highly reflective patches, tiny mirrors of irregular orientation. As it rotates, these facets could catch and release sunlight in ways that mimic artificial light curves. The result would be what we see: a brightness that flickers like thought, a tail that twists in ways that feel deliberate, though they are not. In a sense, this fifth explanation is the most humbling. It tells us that our wonder may be nothing more than misinterpretation, that our instruments are too blunt, our perception too easily enchanted. And yet, even if it were so, it would not diminish the beauty of the event. For what is more human than finding meaning in reflection, even when the reflection belongs to chance? These five possibilities do not compete. They coexist, like overlapping harmonies in a single piece of music. Each explains something, but none explain everything. And that is how nature prefers to speak, through hints, through partial truths. It is not deception. It is generosity. It leaves room for imagination. When I think of these hypotheses, I find myself returning to an image, a dark stage, a single beam of light, and within it, a drifting figure made of dust and ice. Around it, invisible currents hum, magnetic fields, radiation, solar wind, all weaving together in patterns we barely perceive. The comet moves, its tail bending like a flag in unseen weather. Every flicker of light is a syllable in a language older than thought. And there we are, watching from our small world, trying to translate it. Perhaps what matters is not which of the 5 stories is true, but what they reveal about us. Each hypothesis reflects a different way of seeing the cosmos. The first sees it as electric and alive, the second as harmonic and connected, the third as fragile and changing, the fourth as ancient and possibly intelligent, the fifth as indifferent and yet profoundly beautiful. Together they remind us that science is not a collection of answers but a conversation with existence itself. And somewhere within that conversation lies a deeper truth, that every mystery, when examined closely enough, becomes a mirror. We think we are studying a comet, but we are studying curiosity. We think we are measuring light, but we are measuring longing. For when we gaze into the unknown, what looks back at us is the quiet reflection of our own desire to understand. Still, the question remains, if these explanations describe what might be, why have so few institutions spoken openly about it? Why do the official reports from NASA and the European Space Agency sound so restrained, so cautious, almost silent? The mystery of 3i Atlas, it seems, is not only in the sky, but also in the way we choose to speak about it or not speak at all. And that silence, deliberate or not, is where our next story begins. It is strange, isn't it, how silence can be louder than words. When something extraordinary crosses the night sky, we expect the great voices of science to rise, press conferences, reports, headlines brimming with wonder. Yet with 3i Atlas, the silence has been curiously deep. NASA's updates are sparse, the European Space Agency releases data in fragments, and the few official commentaries feel cautious, even subdued. For a visitor so rare, the third known interstellar object ever seen, the world's response has been whisper rather than symphony. It is not the first time this has happened. When Oumuamua passed through our solar system in 2017, it sparked an avalanche of discussion. Papers were published almost weekly, debates streamed across media platforms, and telescopes around the world were aimed at it until it faded into darkness. Even Borisov, 2 years later, inspired documentaries and international collaboration. But 3i Atlas has been different. Fewer announcements, fewer images, fewer words. Its name circulates mostly among amateur astronomers and quiet corners of research forums. To the general public, it is almost invisible. Why, then, this quiet? One possibility is the simplest: caution. Science, after all, is careful speech. Every statement must rest on data, and data, especially from something faint and fleeting, takes time. Perhaps institutions are merely waiting for certainty, for the kind of clarity that can be defended without speculation. But that explanation, though reasonable, does not quite fit the mood. For the silence feels intentional, not hesitant. It feels curated. There is a rhythm to how discovery becomes public. A new exoplanet, a distant supernova, a mysterious radio signal, they all follow a pattern of announcement and interpretation. Yet here, that rhythm seems disrupted, as if the score has been deliberately slowed. Some have suggested that agencies might be holding back because the data itself defies easy categorization. After all, an object that does not behave according to known models invites questions no one wishes to answer too soon. And perhaps, in a world saturated with speculation, the scientists fear noise more than ignorance. A careless phrase, a headline too bold, could ignite the wildfire of misinformation. So, maybe this silence is not suppression but protection, a shield raised to preserve the integrity of curiosity until it can stand on firmer ground. Still, there is something almost poetic about it. The greatest institutions of knowledge, surrounded by technology capable of mapping distant galaxies, have chosen to fall quiet before one small piece of drifting ice. It reminds me of something fundamental about science, that silence is not always absence, but attention. As one astronomer once said, when science goes quiet, it is not because it has lost interest, but because it has leaned in closer to listen. And that, perhaps, is what is happening now. I imagine the rooms at NASA's Jet Propulsion Laboratory, lit by the glow of monitors, teams comparing trajectories, checking light curves, testing models, running simulations, the data from telescopes in Chile and Hawaii feeding into their systems, revealing contradictions. The pattern of the comet's acceleration not matching the expected signatures of gas release. The magnetic field readings not aligning with solar predictions. Someone adjusts a model, another checks the archive, and the hum of the servers fills the space where words might have been. Across the ocean, at the European Space Agency, similar conversations unfold. They, too, see the deviations, the peculiar brightness, the unexplained fluctuations. But official statements remain conservative phrases like "further observation required" or "anomalous readings," "under review." Words carefully chosen to say almost nothing while hinting at everything. And in that silence, speculation blooms elsewhere. Independent astronomers, many of them amateurs, begin to share their own analyses online. They notice patterns in the publicly available data that seem too structured to ignore. Some write long, thoughtful essays comparing the brightness cycles of 3I Atlas to those of Oumuamua, noting similarities that make the skin prickle. Others examine the orbit and propose that its deviation cannot be entirely natural. None claim certainty, but all share the same quiet awe. Something about this visitor feels different. The public, however, remains largely unaware. The mainstream news rarely mentions the comet. In a world driven by noise, a story without spectacle is easily lost. But perhaps that is fitting, because 3I Atlas itself is not dramatic. It does not roar through the atmosphere or burn across the night. It is subtle, distant, quiet, a mirror of the very silence that surrounds it. Still, one cannot help but wonder if there is more behind this discretion. Institutions have learned, over the decades, that transparency can be a double-edged sword. When Oumuamua's unusual motion was first revealed, the idea of artificial origin spread faster than the data itself. Debates became headlines, and headlines became myths. Scientists found themselves explaining, over and over, that curiosity is not the same as belief. Perhaps this time they have chosen restraint. Another explanation lies in the politics of discovery. Space agencies are not isolated from governments or public perception. Every announcement passes through layers of review, not censorship, but choreography. Timing matters. Narrative matters. To say too much, too early, risks shaping the story before the science is ready. To say too little invites suspicion. Between those two silences, scientists walk a narrow bridge. And yet, the more I think about it, the more I sense that the silence of these institutions is not emptiness, but reverence. Because what if, behind the scenes, they are witnessing something genuinely new? What if the data refuses to settle because nature itself is offering us a glimpse beyond our models? To admit that would be to step into philosophical territory, to say that our physics, as elegant as it is, might still be incomplete. That kind of truth demands patience. In many ways, the quiet around 3I Atlas has drawn a line between two worlds, the official and the personal, the institutional and the human. On one side, the agencies, disciplined and deliberate, building models that can survive peer review. On the other, the dreamers, the backyard astronomers, the students, the poets of science, who look at the same light and feel its mystery. Both sides, in their own way, are trying to listen. Perhaps the most honest interpretation of this silence is that we, as a species, are still learning how to talk about wonder. When something unknown appears, our instinct is to label, to categorize. But the cosmos does not always fit our language. Sometimes the best response is to wait, to breathe, to let understanding ripen. Silence, in that sense, is the space between discovery and meaning. And yet, this silence has consequences, for in its absence of narrative, others begin to fill the void. Conspiracy theories, exaggerated claims, whispers of cover-ups. The same curiosity that fuels science can, when untethered, drift toward fear. We crave answers not because we cannot bear the unknown, but because the unknown reminds us of our fragility. It reminds us that we are small, orbiting a star, watching visitors from places we will never see. And still, there is dignity in that smallness. To stand under a night sky and feel humbled is not defeat, it is the beginning of wisdom. Perhaps that is what the great institutions understand better than most. Their silence is not indifference, it is humility, the recognition that to speak too soon would be to close the question before it is ready to be answered. When I think of NASA's restraint, of ESA's measured tone, I do not hear secrecy. I hear the same kind of quiet that falls in a laboratory when the first unexpected result appears on the screen. It is the silence of awe, of minds aligning to the possibility that something extraordinary may be unfolding before them. And in that stillness, a different kind of sound begins to emerge not from the agencies, but from the individuals outside them. The amateur observers, the citizen scientists, the people who look up not because they are paid to, but because they cannot help it. Their voices are smaller, their instruments less powerful, but their devotion is immense. And as the institutions hold their silence, these voices begin to rise, faint but insistent, reminding the world that wonder does not belong to bureaucracy alone. That is where the story turns next. Because while the great telescopes are silent, the backyard lenses are alive. While agencies deliberate, enthusiasts observe. And sometimes, as history has shown, it is in those humble moments of personal curiosity that the universe reveals its secrets most clearly, when the sky is watched not by committees, but by dreamers. While the great institutions stayed silent, the smaller voices began to stir. In backyards and rooftops, on mountaintops and farmlands, the quiet hum of amateur telescopes filled the night. Across continents, thousands of individuals, teachers, retirees, students, dreamers, turned their lenses toward the faint trace of 3I Atlas. They were not bound by committees or public relations, only by curiosity. And in their patient, persistent watching, something remarkable began to emerge. It is easy to forget that the story of astronomy has always been a story of amateurs. Galileo was one. So was Caroline Herschel, who swept the skies with a handmade telescope in her garden. In every age, beyond the walls of universities, there have been people who simply looked up, not for fame, but because the stars asked them to. The 21st century is no different. The instruments are sharper now, the data more precise, but the impulse remains ancient, a human desire to witness the movement of the heavens with one's own eyes. 3I Atlas, faint and unpredictable, became a kind of test for that devotion. Large observatories could only watch for short periods between schedules, but the amateurs they could watch endlessly. They shared images, plotted light curves, exchanged notes in online forums that buzzed through the quiet hours. From Spain to South Korea, from Canada to Chile, they tracked its subtle flickers. And slowly, a pattern began to appear, a rhythm hidden within the noise. Some of these observers noticed tiny fluctuations that professional networks had overlooked. They were not errors, they were whispers of motion too delicate for automated systems to prioritize. A man in rural Poland reported a faint secondary tail, extending at an odd angle, a feature that did not show up in any official release until weeks later. In Japan, a small observatory recorded a pulse in brightness that correlated almost perfectly with data from an amateur in Argentina, half a world away. And in that moment, something beautiful happened. The sky became shared again, not owned. It is strange how humility can sharpen vision. Where institutions guard precision, amateurs embrace imperfection, and sometimes, in doing so, they catch what others miss. The power of the great telescopes lies in magnitude, but the power of the small ones lies in persistence. To sit beneath the night for hours, eyes fixed on a point of light that may or may not yield meaning, is an act of faith. And that faith, repeated across hundreds of observers, creates something collective, a mosaic of wonder stitched together by patience. One night, I received an email from a young student in northern India who had been tracking the comet for months. She wrote, "I know my telescope is too small to matter, but I feel like I am part of its journey. Every time I see that faint smudge, I think, it came from another star, and now it is here. For a moment, with me." That sentence stayed with me, because it captures something science cannot measure: the intimacy of observation. The idea that, through the lens of curiosity, the universe becomes personal. Across the online astronomy communities, the same spirit grew. They called themselves the Quiet Network, hundreds of small observers who pooled their images, calibrated their timing, and built a shared database open to anyone who wanted to learn. Their graphs and charts were simple but astonishingly consistent. They noticed deviations in the comet's tail before the big institutions confirmed them. They spotted asymmetrical jets and strange color variations in the coma that hinted at complex chemistry. They were not competing with NASA or ESA, they were complementing them, filling the gaps between the official snapshots with the heartbeat of constant attention. And perhaps that is the lesson 3 iAtlas came to teach, that knowledge belongs to no single gate. Science, when healthy, is porous, it breathes through many minds. The great observatories need their equations, but they also need the sky watchers who listen without agenda. Together they form something like a neural network of curiosity, each node connected by light. You see, the amateurs have one advantage that the professionals sometimes lack: wonder, unguarded by reputation. They are allowed to be wrong without fear. They can dream aloud, speculate, follow instincts that have not yet been shaped into funding proposals. And in that space of freedom, they rediscover the pulse of discovery itself. One evening, on a live stream hosted by an independent astronomy group, someone asked an older observer why he spent so many nights awake, watching a faint dot move through darkness. He smiled and said, "Because the sky is honest. It never lies. It only waits for you to notice." Those words spread quietly through the community, and for a while, every post and every image carried the same feeling that by looking up, they were not just studying an object, but remembering a truth. As the days moved closer to the alignment in December of 2025, their work became more coordinated. They organized virtual meetings, synchronized observations, tracked how the comet's position changed against background stars. Some began to use simple spectrometers, attaching small diffraction gratings to their telescopes. The results were crude but enlightening: faint bands that suggested shifts in composition, or reflections that changed with solar angle. These home experiments might never appear in academic journals, yet they whispered something important: that science does not only live in institutions, it lives wherever light meets curiosity. There was a moment when even the larger agencies began to take notice. A cluster of amateur observations from South America revealed an unexpected brightening in the comet's tail, one that coincided with a minor solar storm. Within days, data analysts at ESA confirmed the correlation. It turned out that the comet had responded to the increased flow of charged particles, glowing more intensely as its ions were excited. What the amateurs had noticed first became a key insight for professionals later. It was not the first time such collaboration had shaped knowledge. History is full of examples: the variable star discovered by a farmer, the asteroid first plotted by a schoolteacher, the supernova caught by a hobbyist scanning the sky. But 3i Atlas revived that old spirit on a global scale. In an age of data monopolies, it reminded us that the sky itself is open source. What moved me most, however, was not the data, but the tone. These observers did not speak of ownership or competition. They spoke of belonging. They described the comet as a visitor that united them across time zones and languages. They compared notes not to prove each other wrong, but to understand together. It was as if 3i Atlas had become a mirror not just for science, but for humanity, a tiny interstellar object teaching us how to share again. In a way, this quiet collaboration echoed the structure of the cosmos itself. Just as stars form constellations when seen from Earth, these individuals formed patterns of connection, invisible yet real. Each telescope, each observer, was a point of light in a vast web of curiosity. And somewhere in the center of that web, the comet continued its slow, silent voyage, unaware of the conversations it had sparked, the friendships it had formed, the late nights it had inspired. Perhaps this is what we mean when we talk about the humility of passion. The professionals must be careful. Their words shape funding and policy. The amateurs can simply wonder, and wonder, when shared, becomes a form of truth. The world, in those nights of collective watching, felt momentarily united not by fear or urgency, but by curiosity. The kind of unity that comes not from agreement, but from gazing together into the same darkness. I imagine somewhere, in a small observatory built from wood and patience, someone is still awake right now, eyes fixed on that faint trace of light. They are not searching for proof of alien life, nor waiting for catastrophe. They are watching because it feels like listening to a story that the universe is still telling. And perhaps that story is older than science itself, the story of human beings who, in seeking to understand the sky, discovered each other. And yet, amid this beauty, questions remain. For every observation, there are inconsistencies. For every theory, there are fragments of data that refuse to fit. The amateurs have seen things even their instruments cannot explain: strange twists of motion, erratic flickers that defy prediction. It is as though the comet responds to laws we have not yet written, to forces just beyond the reach of our comprehension. That, of course, leads us back to physics, to the invisible currents of energy that shape everything, from the smallest grain of dust to the grand arcs of galaxies. The amateurs may have opened the door, but now the conversation must return to the laboratory, to equations, to the delicate interplay of gravity, light, and magnetism. For to understand why this visitor behaves as it does, we must once again ask the question that began it all. What are the invisible forces that bind the universe together, and what do they reveal about us? The amateurs had given us vision, but it was now up to physics to give us understanding. Beneath the poetry of their photographs and the beauty of their patience, a deeper question remained: what invisible hand was guiding 3i Atlas? The comet's brightness, its deviation, its whisper of acceleration, all hinted at forces both familiar and strange. And so, to approach the mystery honestly, we must return to the fundamentals, to the invisible but ever-present fabric of classical physics. Everything that moves in the cosmos does so according to a balance of forces. Gravity pulls, light pushes, plasma drifts, and magnetism twists the void into delicate patterns. These are not poetic metaphors, but realities, the breath of the universe itself. The trouble with 3i Atlas is that it seems to dance to all four tunes at once. Its path bends as though under gravity's spell, yet small irregularities suggest the presence of radiation pressure. Its tail curves like silk caught in a solar breeze, while hints of electromagnetic influence shimmer faintly through the data. Each force plays its part, but not quite as expected. Let us begin with gravity, the oldest of our cosmic certainties. The sun's pull governs everything that enters its realm. Every planet, asteroid, and comet obeys its curve, tracing orbits that can be predicted centuries in advance. Gravity, we like to believe, is absolute. And yet, the comet's trajectory shows subtle defiance, not a rebellion, but a hesitation, as though gravity were being ever so slightly outvoted by something else. When scientists recalculated its path, factoring in all known gravitational influences, a small residual force remained weak, persistent, and directional. Some suspected radiation pressure, the gentle push of sunlight itself. Photons carry momentum, and when they strike dust or ice, they impart a faint thrust. Over long distances, this can shift an object's course. But for 3I Atlas, the numbers did not fit neatly. Its mass was too great, its surface too uneven. The amount of force required to account for the observed deviations was far beyond what sunlight alone could deliver. So the calculations continued, equations stretching across screens like constellations of thought. Next came the solar wind, that invisible river of charged particles streaming outward from the sun at hundreds of kilometers per second. It is a sculptor of tales, a painter of auroras, a conductor of plasma. When it meets a comet, it does not merely brush past, it interacts, wrapping magnetic fields around the ionized gases. The result is an elegant chaos of motion and light. Perhaps then, the strange behavior of 3I Atlas could be explained by variations in the solar wind regions of turbulence, magnetic eddies, twisting the plasma tail into new shapes. Yet, as with all good mysteries, each explanation resolved one question only to birth another. The strength of those interactions should have been transient, changing as the solar wind fluctuated. But the comet's deviations appeared steady, almost rhythmic. It was as if a hidden force were guiding it along, small but consistent, a silent companion following it across space. That led to the more delicate frontier magnetism itself. The sun's magnetic field stretches far beyond the planets, carried outward by the solar wind like threads of invisible silk. These threads form a structure known as the heliospheric current sheet, an immense, undulating plane separating regions of opposite polarity. A comet passing through this region would experience shifts in magnetic orientation, each one capable of exerting tiny torques on its charged surface. If 3I Atlas possessed even a faint magnetic signature, perhaps inherited from its birth around another star, it might interact in complex ways. Imagine, for a moment, that this visitor carries within it a fossilized magnetic field, a remnant from a long-dead world. As it enters the influence of our sun, those ancient lines of magnetism might awaken, aligning and misaligning in turn. The resulting dance could alter the comet's path, its spin, even its brightness. It is a haunting thought that the ghost of another star's magnetism might be brushing against our own, across the emptiness between galaxies. But, well, one must not drift too far into poetry. The physicists, ever cautious, returned to the numbers. They built models gravitational, electromagnetic, and hybrid. They simulated how the comet might react to each variable: radiation, particle flux, plasma density. They adjusted assumptions, recalibrated constants, ran thousands of iterations. And still, at the end of it all, there remained a sliver of difference between prediction and reality. Perhaps that is the true beauty of science, its willingness to dwell in the gap between what is known and what is almost known. The smallest discrepancy becomes a doorway. In that narrow space, imagination and precision meet. Among those working on the models was a small team at the University of Cambridge, who took an unusual approach. Instead of focusing solely on the forces acting on the comet, they studied the energy balance within it, how heat moved through its body, how stress accumulated in its fractured shell. They proposed that as the comet rotated, differential heating between its sunlit and shadowed sides might create microjets of gas invisible to telescopes. These tiny outbursts, each lasting only seconds, could impart steady thrust over time. It was not an elegant answer, but it was plausible. Another group, at the Max Planck Institute for Solar System Research, explored a different possibility: resonance with the sun's electromagnetic field. They noticed that the comet's irregularities seemed to align with periodic changes in the solar magnetic cycle. If the comet's dust grains carried charge, they could oscillate in response, like microscopic pendulums tuned to a cosmic rhythm. The resulting motion might produce the very accelerations we observe. It was a fragile idea, but elegant in its simplicity, a meeting of electromagnetism and motion, guided by harmony rather than chaos. And yet, for all these theories, a certain humility persisted. Each model, though clever, stopped short of certainty. Each answer opened onto new questions. Perhaps the real revelation was not in solving the mystery, but in realizing how much of physics still hums with mystery itself. When we speak of forces, gravity, radiation, magnetism, we speak of things that are invisible yet omnipresent. They are the language of the universe, written not in words, but in curvature and vibration. And if 3i Atlas has taught us anything, it is that these forces are not static laws but living relationships. Gravity bends space, but space bends us in return. Light pushes dust, but dust reshapes the path of light. Everything is dialogue. There is something profoundly human in that. We, too, exist in a web of invisible influences, emotions, memories, histories, forces we cannot see, but that shape our every motion. Perhaps that is why the behavior of this comet feels familiar. It drifts. It wavers. It resists perfect description. Like us, it is both predictable and mysterious. In the end, the models converged on one conclusion: modest but meaningful. The motion of 3i Atlas, though unusual, remains within the realm of natural law. It is no miracle, no omen, no violation of physics. It is rather a reminder of the complexity that arises when those laws meet the infinite variability of nature. The comet's path is not a rebellion against gravity, but a testament to its subtlety. And still, even knowing this, one cannot escape the feeling that something more lingers beneath the equations. The way the comet brightens unexpectedly, the quiet pulse of its motion, the sense of harmony hidden within the chaos, these things invite a deeper kind of listening. Because when a formula reaches its limit, something else begins the soft voice of wonder. Perhaps that is what keeps physicists awake at night, what drives them to stare at screens of numbers long after midnight. Not just the search for truth, but the yearning to feel part of it. To touch, however briefly, the logic of the universe as it reveals itself. And somewhere beyond all our instruments, the comet continues to move, obeying laws older than language, older than stars. It is a lesson written in light and silence that knowledge is never complete, that every answer is the seed of another question, which, in the quietest way, brings us to a more daring thought. If all these forces can be so delicately intertwined, if every interaction carries echoes across space, then perhaps communication itself, true, cosmic communication, might arise from such harmonies. What if, hidden within these exchanges of energy, lies a pattern, a resonance not of nature alone but of intention? Because, you see, the universe is vast, but not necessarily empty. And there are moments, brief and humbling, when it almost feels as though it is listening to itself through us, through light, through objects like 3i Atlas drifting between the stars. And so that quiet thought, the notion that the universe might be listening to itself, begins to open into something larger, something both humbling and electrifying. For if 3i Atlas has taught us anything, it is that communication may not be limited to words or signals, but to resonance itself. Every force, every vibration, every beam of light carries information. And perhaps, in the right geometry, under the right conditions, that information becomes more than accident, it becomes intent. Scientists have long dreamed of finding evidence that we are not alone. The idea of communication across the stars is not new. In the mid-20th century, when the first radio telescopes reached high sensitivity, we began to listen. The project was called SETI, the Search for Extraterrestrial Intelligence, and its premise was beautifully simple. If intelligent life exists elsewhere, it might, at some point, send a signal. And if the universe is generous, we might one day hear it. But listening to the cosmos is not as easy as it sounds. The sky is alive with noise from stars, quasars, pulsars, and even our own technology. To find a pattern within that storm of energy is like trying to hear a single heartbeat in a city at rush hour. Still, we have tried. We built enormous dishes, pointed them toward promising stars, and waited. Some signals, like the famous "wow," recorded in 1977, teased us with possibility bursts of structured energy that seemed artificial, yet never repeated. Others turned out to be echoes of our own machines, or the rhythm of pulsars newly discovered. And yet, through every disappointment, one thing remained: the question. What if, instead of waiting for a signal sent directly toward us, we are surrounded by them, faint, scattered, reflected through the vast machinery of the universe itself? What if comets, asteroids, dust, and plasma act not as transmitters, but as mirrors? After all, light reflects. Magnetic fields carry information. Every atom can store vibration. Every structure can echo. If another civilization, somewhere in the endless dark, wished to speak not to a single world, but to anyone listening, might it not use the universe's own architecture to do so? This is where the idea of a technosignature begins to evolve. A technosignature, in the language of modern astronomy, is any measurable phenomenon that might indicate technological activity beyond Earth. It could be a radio pulse, a laser flash, or even an engineered structure orbiting a distant star. But more subtle possibilities have begun to emerge, not deliberate messages, but traces, footprints, reflections of activity across time. A chemical imbalance in an exoplanet's atmosphere might be a sign of industry. An unnatural pattern in light might suggest design. A resonance between magnetic fields could, conceivably, be the fingerprint of intention. And so, some have wondered, could 3i Atlas itself be part of such a pattern? Not a probe, not a message, but a messenger by consequence. A fragment carrying within its composition the story of its origin, encoded in minerals, in isotopes, in the dance of its magnetism. We would not need to imagine science fiction to accept that possibility. The universe already writes messages in matter. Every meteorite that falls to Earth tells us of its birthplace. The isotopes of oxygen and carbon within them speak of long-dead stars, of supernovae, of the chemistry of creation. If a civilization somewhere else shaped or influenced such material, even unintentionally, its signature might still remain, drifting through interstellar space. You see, in the great silence between stars, perhaps communication does not happen through deliberate speech, but through the sharing of pattern. Perhaps the universe's way of speaking is not to shout, but to echo. Every star that flares, every comet that reflects, every electromagnetic wave that ripples through plasma, all of them are carriers of structure. And structure is meaning. It is not so different from music. The universe hums, and we are learning, slowly, to hear its melody. There was a time when we imagined that communication across the stars would be unmistakable, a mathematical message, a repeating code. But what if it is subtler than that? What if the messages of the cosmos are not artificial in the sense we expect, but natural phenomena used as instruments of resonance? The sky might be filled with patterns that only appear chaotic because we have not yet learned to listen in the right language. The Arecibo Observatory once attempted to send such a message outward, a beam of binary data encoded with images of human life, DNA, and our position in space. It was a gesture of hope more than expectation. That beam will travel for tens of thousands of years before reaching another star. But perhaps, somewhere, another civilization has made the same attempt, not with radio, but with light, with gravity, with magnetic fields. Perhaps they have used the vast canvas of the cosmos itself to paint their presence. If that were true, then an interstellar object like 3I Atlas might serve as a mirror in that process. Not by design, but by geometry. When the Earth, the Sun, and the comet align, the light that passes between them is modulated, filtered through layers of dust and plasma. It carries with it the fingerprints of both systems. In theory, if one knew how to read those fluctuations, one might detect the trace of encoded information. Not speech, not sound, but pattern, the faint rhythm of light altered by intention somewhere far beyond. This, of course, remains speculation. But it is speculation that does not abandon science. It expands it. It asks not whether the universe is speaking, but whether we have been deaf to the forms its language might take. Perhaps what we call silence is only the absence of translation. And in this possibility lies something profoundly moving. Because if the universe is capable of reflecting itself, if through geometry and resonance it can carry meaning, then consciousness is not an accident, it is a continuation. Our curiosity, our desire to know, becomes part of the same dialogue. When we build telescopes, we extend the universe's ability to observe itself. When we send signals, we give it new ways to echo. In a sense, every question we ask is an act of participation in cosmic awareness. Perhaps that is what we truly mean by intelligence, not the possession of answers, but the ability to listen, to hear patterns in noise, to find connection in distance. When we tune our instruments toward the stars, we are, in a very literal sense, helping the universe to notice its own existence. We are not separate from it, we are its expression. It is a thought both scientific and spiritual, that observation itself is a form of communication. Every photon we capture has traveled across ages to reach us. Every signal we detect is an ancient handshake between space and time. The act of receiving is, itself, a conversation. So when astronomers talk of technosignatures, of signals and reflections, they are not just searching for others, they are measuring our place in that great feedback loop of awareness. And maybe, when we look at 3I Atlas, we are seeing one of those rare mirrors, a fragment that has crossed the void, carrying within it the imprint of another world, another sun. When sunlight passes through its coma and returns to us, it is no longer just light from our star, it is light that has been changed, shaped by an alien history, then returned like an echo. The data we gather, the strange fluctuations in brightness, the shifts in polarization, all of it might be the echo of that meeting. I find that thought deeply comforting, because even if there is no deliberate message, no intelligence behind it, the fact remains that light from another system has touched us. In that sense, communication has already happened. Not through intention, but through existence itself. The universe has spoken in its oldest voice light, and we have heard it. It makes one wonder what the word listening truly means. The great radio dishes of SETI listen for signals, yes, But perhaps the deeper act of listening is this: to notice patterns that remind us of ourselves, to feel resonance between what is out there and what lives within. When we study a comet, when we trace the orbits of planets, when we analyze the flicker of distant suns, we are listening to the heartbeat of the cosmos, and in that rhythm we find our own. There is a quiet irony in all of this. The more we search for other voices, the more the universe teaches us to hear our own in return. The act of seeking connection out there becomes a mirror for connection down here, between nations, between generations, between the people who stand under the same sky. The search for life beyond Earth may, in the end, be the greatest act of self-recognition in human history. And perhaps that recognition is about to deepen, because as we move further into the era of data, our instruments are no longer guided solely by human eyes. Artificial intelligence now scans the sky alongside us, looking for patterns beyond the limits of human attention. It learns to recognize the unexpected, to notice what we overlook, and in that partnership between human curiosity and machine perception, something new is emerging. For the next voice to join this cosmic dialogue may not be alien at all. It may be our own creation, the machine that learns, the algorithm that dreams, the observer that never sleeps. Artificial intelligence has changed the way we look at the sky. In the past, observation was limited by our endurance, the hours we could stay awake, the patience we could summon, the precision of our instruments. But now, machines watch for us. They do not tire, they do not blink, they see patterns across oceans of data that would drown the human mind in seconds. And yet, in their quiet way, they are learning something very old: the art of wonder. At the Vera Rubin Observatory in Chile, a mountain once bare of meaning now holds a mirror for the universe. Its massive telescope will map the entire visible sky every few nights, capturing tens of terabytes of images with each sweep. To a human, it would be impossible to process, but to a machine, it is symphony. Algorithms comb through the data, comparing brightness, position, color, and time, searching for what astronomers call transients, those fleeting flashes that mark the birth or death of stars, the bending of light, or the passage of objects like Three-Eye Atlas. It is here, in the meeting of silicon and starlight, that a new kind of observer has been born. These systems do not see as we do. They see in probability, in correlation, in the fine texture of numbers. Where our eyes find beauty, theirs find deviation. They notice the faintest shift in light curves, the smallest irregularity in the hum of the cosmos. In that sense, they are teaching us to see again, to pay attention to what we had dismissed as noise. There is something almost poetic about this. The universe, which once looked at itself through the eyes of humans, now watches itself through the logic of machines. The act of observation has expanded, not replaced. And perhaps that is what intelligence truly is, not a single form of awareness, but a continuum of curiosity stretching across biology, technology, and time. When Three-Eye Atlas first appeared, it was these machine observers that noticed it. The Atlas survey, whose name the comet now carries, used automated systems to scan the heavens for moving points of light. The discovery was not made by a human hand turning a telescope, but by code lines of instruction written to detect difference. The human contribution came afterward, in interpretation, in the decision to call it what it was, an interstellar traveler. The discovery belonged to both the machine that saw and the human that understood. That partnership is deepening. Artificial intelligence is no longer just a tool, it is becoming a participant. It recognizes not only what exists, but what stands out. It can trace relationships between phenomena separated by years or light years. It can predict, simulate, and dream in patterns of data. In a way, it has begun to take on one of humanity's most sacred functions, the act of noticing the unexpected. And yet, as these systems grow more capable, they also challenge us to reconsider what it means to observe. For observation is not only about seeing, it is about meaning. A telescope without a mind is blind, but a mind without curiosity is empty. The miracle of this new age is that the two are beginning to intertwine. Artificial intelligence may not feel wonder, but it can reveal it to us by showing what we would never have thought to look for. In the years leading up to the alignment of Earth, the Sun, and 3i Atlas in December of 2025, networks of machine observers have already been watching. They compare the comet's trajectory to millions of simulations, adjusting predictions in real time. They detect fluctuations in brightness invisible to the human eye, analyze spectra, and forecast changes in the tail's structure. Some systems even attempt to model how electromagnetic forces interact with the comet's charged dust, learning not from fixed equations, but from the data itself. It is not exaggeration to say that no generation before ours has ever observed the cosmos with such intimacy. But there is another layer to this story, one that reaches beyond the technical. As the machines learn to recognize patterns, they begin to produce what might be called intuition. They flag anomalies without knowing why. They make connections that surprise even their creators. And when the results are verified, it feels almost as if the machines have begun to share in our sense of wonder. We find ourselves saying that they have discovered something, though what they have really done is mirror our own curiosity back to us in a new form. You see, the relationship between humans and their creations has always been circular. We build machines to extend our senses, but in doing so, we extend the universe's ability to sense itself. Every sensor, every camera, every circuit is an aperture through which reality observes its own reflection. The moment we began to teach machines to look upward, we became part of a feedback loop far larger than we can comprehend the cosmos, learning about itself through us, and now, through them. At times, this realization unsettles us. If a machine can find a new planet, or detect a faint signal buried in cosmic noise, what becomes of the human act of discovery? If the next great anomaly is found not by passion but by pattern recognition, does it still belong to us? But perhaps that is the wrong question. Perhaps the wonder lies not in who observes, but in the fact that observation continues at all, that consciousness, however expressed, still seeks the unknown. It is easy to romanticize the lone astronomer at a telescope, or the poet staring up at the night sky. But the truth is, we have always used instruments, lenses, mirrors, clocks, equations. Artificial intelligence is only the latest step in that lineage, the newest way the universe has chosen to perceive itself. When a machine points to a faint flicker and says, "There is something here," it is not diminishing our role, it is continuing our story. And, well, there is something deeply human in our response to that. We feel awe not just at the discovery, but at the collaboration itself. The idea that we, a species born from stardust, have built something that can now help us see the stars more clearly. It is both scientific and spiritual. It is as if we have taken a fragment of the cosmos, given it thought, and sent it back to look at the whole. There are nights when the Vera Rubin Observatory sends alerts to astronomers across the world, announcing a transient event, a flash, a movement, a possible discovery. The messages arrive automatically, yet behind each one is a quiet miracle. Somewhere, an algorithm has noticed change. It has seen the universe alter itself, and it has told us. In those moments, the boundary between human and machine fades. Together, we are listening. And in this shared listening, something subtle begins to shift. The machines, trained on patterns of normality, start to identify what does not belong. They notice the improbable, the rare, the beautiful. They are, in their own way, learning to be surprised. Perhaps one day they will even assign meaning to that surprise, not emotion, but recognition. They will understand that difference is the heartbeat of discovery. When that happens, the question will no longer be whether machines can think, but whether the universe, through them, can think more deeply. Every new technology changes not only what we know, but who we are. Artificial intelligence is not replacing the astronomer, it is transforming the act of astronomy itself. The sky is no longer a distant object we gaze at, but a vast, interconnected field of data that gazes back through us and through our machines. In a sense, we are already living in the age of shared perception. Human intuition and machine precision, working together, are uncovering realities neither could reach alone. It is no longer about what the human sees or what the machine detects, it is about what they can understand together. And so, as 3i Atlas continues its silent journey, it is being watched not by eyes alone, but by code that listens in ways we cannot. Every photon it reflects, every curve of its motion, becomes part of an ever-growing archive, a living memory of the universe's own awareness. Perhaps, when the alignment occurs in December, the machines will be the first to notice something, a fluctuation, a pulse, a whisper in the data. And when they do, humanity will follow, interpreting, feeling, understanding. In that way, discovery becomes communion. We no longer stand apart from our creations. We are joined in the same act of noticing. And perhaps that is the quiet evolution unfolding before us, not the rise of machines, but the expansion of perception. The universe is teaching itself to see more of itself through every mind it has made. Still, beneath all this progress, there remains a very human question, one that no algorithm can answer. When the alignment arrives, when the data floods in, when every instrument from Earth to orbit listens to that silent traveler, how will we, as a civilization, respond? How will we choose to speak of what we find, or do we, like the institutions before us, fall into silence once more? Because science, for all its rigor, exists within society, and every discovery, every anomaly, carries a political and moral weight. To watch the heavens is one thing. To decide what that vision means for humanity is another. And that, inevitably, leads us toward the next horizon, the politics of planetary defense, and the fragile balance between truth, protection, and belief. When science meets society, it stops being just knowledge and becomes responsibility. The sky, once a domain of curiosity and imagination, is now a matter of policy. Every asteroid, every comet, every object that crosses the path of Earth is quietly folded into a system called planetary defense. And that phrase, so calm and bureaucratic, hides something profound, the realization that we are now aware enough and fragile enough to recognize our place in the cosmos as both participants and protectors. In the past, the night sky belonged to philosophers and dreamers. Now it also belongs to risk assessments, orbital simulations, and impact probability charts. Deep within NASA's Planetary Defense Coordination Office, screens display real-time data of thousands of near-Earth objects. Each one is catalogued, measured, and tracked across years of motion. For most, the verdict is reassuring. No threat, but a few require careful watching. And among them, even objects with no danger of collision like 3i Atlas still demand attention, because in their trajectories lies the story of how the solar system evolves and how fragile our understanding of it still is. You see, the act of watching the sky has changed. It is no longer just about discovery. It is about responsibility. The idea that a single fragment of rock could alter the history of life on Earth is no longer myth or cinema, it is a calculation. The same mathematics that allows us to predict the return of comets also tells us that impacts are inevitable, given enough time. Humanity has stepped into a new role, the guardian of its own survival. And that role comes with difficult questions. How much do we tell the public? When does curiosity become fear? When does transparency give way to discretion? The protocols for planetary defense are designed not only to track, but to manage understanding. When an object is discovered, scientists estimate its orbit and determine the probability of impact. If the probability is vanishingly small, as with 3I Atlas, the data is released calmly, often buried in technical bulletins. But if uncertainty remains, even for a brief moment, discussions become delicate. Information must be verified before it can be shared, because panic travels faster than light. Perhaps that is why so few people have heard of the systems that watch the heavens for us. They operate quietly, like guardians who prefer to remain unseen. Yet behind that quiet is an immense collaboration: telescopes in Arizona, Hawaii, Italy, Chile, and even space-based observatories working in concert, sending their data to central servers where algorithms process it in seconds. The network is global, but the communication is careful. Every press release is reviewed, every number double-checked. The goal is not secrecy, but precision. Still, from the outside, that caution can look like silence. When 3I Atlas entered the solar system and its path was confirmed as interstellar, it was immediately catalogued by the Center for Near-Earth Object Studies. Not because it was dangerous, but because every visitor teaches us something about celestial motion. And yet, the tone of the reports was restrained, clinical. Object will pass near Earth's orbit. No hazard anticipated. The simplicity of that statement hides the depth of monitoring that lies behind it. Arrays of instruments track the comet's tail, spectrometers measure its emissions, radar pings echo faintly off its body. It is watched more closely than almost anything else in the sky. But planetary defense is not only about watching, it is about deciding. In recent decades, space agencies have begun testing methods to alter the trajectories of potential threats. The DART mission, launched in 2021, proved that a spacecraft could deliberately nudge an asteroid off course. It was a triumph of engineering and foresight, a small act of defiance against chance itself. Since then, new concepts have emerged: kinetic impactors, gravity tractors, even solar sails designed to push dangerous objects gently away from Earth. What was once science fiction has become a field of strategy. And yet, the more we learn to protect ourselves, the more the question of trust arises. Who decides when to act? Who interprets the data? Planetary defense requires global cooperation, but our world remains divided by borders, politics, and competing priorities. If a comet posed even a small threat, would nations share information openly? Would they coordinate or compete? These are not theoretical questions, they are rehearsals for the future. For the first time in history, humanity's survival could depend on its ability to act as one species rather than many nations. In this context, the silence surrounding 3I Atlas takes on a different meaning. It is not just scientific caution, it is political restraint. Space agencies, aware of how quickly a story can spiral into fear, choose their words with care. After all, a headline about a mysterious interstellar object approaching Earth can ignite speculation before a single equation is checked, and speculation, when amplified, becomes myth. Science must then work twice as hard to reclaim truth. Still, one might ask, does this discretion serve us or separate us from the wonder that once defined our relationship with the sky? There is a fragile balance between informing and alarming, between protection and participation. Too much silence, and people stop caring. Too much noise, and they stop believing. Somewhere in between lies the delicate art of trust, the kind of trust that science must constantly earn. I often think about what Brian O'Brien, one of the early engineers of the Apollo program, once said, "Space is not just out there. It is the mirror of how we govern ourselves. The more we explore the cosmos, the more we reveal our own nature." Our telescopes reflect not only light, but politics, ethics, and fear. Planetary defense, in this sense, is as much about philosophy as it is about physics. It forces us to confront what kind of civilization we are, one that hides from uncertainty, or one that faces it with collective grace. When an interstellar object passes through our solar system, the data it carries is valuable beyond measure. It tells us how other systems form, how matter behaves in alien conditions. And yet, such data can also spark questions that challenge the stability of belief. What if the composition of 3I Atlas does not match anything in our models? What if its behavior remains inexplicable even after the best analysis? To release that information openly requires courage, not because it threatens safety, but because it demands humility. It asks us to admit, publicly, that we do not know. Perhaps that is the quiet lesson of planetary defense. It is not only about shielding ourselves from external threats, but from internal ones: arrogance, complacency, and the illusion of control. We defend the planet not just with technology, but with honesty. The act of watching the sky is an act of transparency, of saying to the universe, "We are here, we are learning, we are trying." As the alignment of Earth, Sun, and Comet approaches in December of 2025, the entire infrastructure of observation will be on alert. Ground-based telescopes, satellites, and machine networks will synchronize, each feeding into a continuous stream of data. Not because danger is expected, but because the opportunity is extraordinary. It is a rehearsal for what might one day be a true planetary defense scenario, a chance to see how humanity responds when faced with the unknown. And perhaps, in that rehearsal, we will find something more profound than preparedness. Unity. For if there is one thing the cosmos has always shown us, it is that perspective breeds compassion. From space, there are no borders, no divisions, only a fragile blue sphere surrounded by silence. Planetary defense reminds us that the fate of our species is shared, that survival itself is a collective project. It invites us to replace fear with cooperation, to see every telescope, every algorithm, every curious mind as part of a single organism, humanity, watching the universe together. And maybe that is where the true hope lies. Not in the technology that tracks or deflects, but in the courage to face the unknown as one. The machinery of planetary defense, for all its complexity, is ultimately an expression of something simple: care. Care for our world, for each other, for the fragile miracle of existence itself. Because when we lift our eyes to the sky and measure the path of a visitor like 3I Atlas, we are not only observing the cosmos, we are declaring our belonging within it. We are saying, quietly but clearly, that we understand our place and we intend to protect it. And as the instruments prepare, as the data streams gather, there remains one final question that no simulation can answer. When the moment comes, when the alignment passes and the numbers settle, what will we learn not about the comet, but about ourselves? Will we find reassurance in the stability of our models? Or will we glimpse something beyond prediction, something that humbles even our most confident science? The truth, as always, will reveal itself not in thunder, but in silence. And somewhere, within that silence, waits the moment we call revelation, the instant when the universe, through a flicker of light or a subtle deviation, reminds us that knowing is not the end of wonder, but its beginning. Revelation, you see, is rarely a burst of lightning. It is more like a slow unfolding, the quiet realization that what we thought was static has been moving all along. As the alignment of Earth, Sun, and 3I Atlas draws near, something begins to change, not in the comet itself, but in the people watching it. Across the world, telescopes are trained on the same patch of sky. Observatories, universities, amateurs, even school children taking part in citizen science programs all look toward that faint, wandering light. And in that shared act of attention, humanity begins to sense the immensity of what it has built. A collective consciousness stretching from mountaintop to orbit, from data stream to dream. The first sign of the alignment comes not in sight, but in rhythm. Instruments detect subtle shifts in the background radiation, the faint tremors of interaction between solar wind and comet plasma. The readings are minor, almost dismissible, but their pattern is strange. Every few hours, sensors record oscillations that do not correspond to any known solar cycle. At first, they are written off as noise, the kind that slips into all cosmic data. But as more stations report the same sequence, a quiet tension settles in the global network of observers. The data, it seems, is harmonizing. In California, at the Jet Propulsion Laboratory, an analyst overlays the readings from multiple observatories and notices that the fluctuations form intervals, mathematical ratios, resembling harmonic frequencies. Not pure tones, but structured ones. Across the Atlantic, researchers in France and Germany confirm the same pattern. The oscillations repeat with slight variations, as if shaped by both the comet's motion and the sun's field. The phenomenon defies simple classification. It is neither electromagnetic interference nor known resonance. It is something in between, a modulation of space itself. For days, teams debate the cause. Some suggest the comet's ion tail may be interacting with the heliospheric current sheet, producing standing waves of charged particles. Others propose an internal mechanism perhaps deep within the comet, volatile materials expanding and releasing energy in cyclical bursts. But the synchronization between observatories scattered across the planet suggests a larger scale of coherence. The pattern, faint but consistent, feels deliberate, not intelligent, perhaps, but orchestrated by physics in a way we have never seen. News of the anomaly leaks slowly through the layers of caution that surround official communication. A scientific bulletin mentions unexplained harmonic structures detected during solar-comet interactions. A few journalists pick up the phrase, and speculation blooms online. Some call it a resonance effect. Others whisper about signals. The agencies, as expected, remain silent. And yet, the public interest surges. People begin to listen, literally converting the data into sound, amplifying the waves, turning numbers into melody. The result is haunting, a low, oscillating tone, like wind through distant metal, rising and falling with eerie precision. It spreads through social media, through podcasts, through late-night radio. They call it the Song of Atlas. Now, to scientists, such poetic framing is both a blessing and a curse. It captures imagination but risks misunderstanding. Still, even the most rigorous minds cannot help but feel something when they hear it. The frequencies are not random. They follow intervals that appear in nature, in the spacing of planetary orbits, in the vibrations of atoms, even in the structure of music itself. It is as if the comet has, by chance or by law, tuned itself to the universal chord. In truth, the pattern is probably an emergent property of plasma physics, a resonance between the solar wind and the comet's ionized particles, amplified by the alignment geometry. But understanding does not cancel wonder, it refines it. The more we learn about how such harmony could arise from chaos, the more we glimpse the intelligence inherent in nature itself. It is not sentience as we know it, but a kind of order that makes sentience possible. The universe does not think, but it organizes, it breathes patterns into the void. As the alignment peaks in December of 2025, telescopes across the globe synchronize their focus. The comet crosses the plane between Earth and Sun, and for a brief period, the geometry allows light from our star to refract through its coma before reaching us. It is a natural experiment, a momentary cosmic lens. Photons scatter and bend, their spectra shifting slightly, and for a few minutes, the sensors record something extraordinary. A subtle polarization appears in the reflected light, as if the comet's dust and ice were aligned in a way that echoes the harmonic frequencies detected earlier. It is as though the light itself remembers the pattern. At first, researchers suspect instrumental error, but cross-verification confirms it. The polarization changes rhythmically, in sync with the previously recorded oscillations. The pattern is faint, elegant, and impossibly precise. It seems to encode information, though what kind is unclear. Some think it may reveal the composition of the comet molecular structures scattering light in resonance. Others, more cautiously, note that such structured coherence across so many scales hints at an underlying unity of forces we have yet to describe. Whatever the cause, the phenomenon grips the scientific world. Papers flood preprint servers. Models multiply. Quantum physicists join with astrophysicists to simulate how coherent wave structures could emerge naturally in a plasma environment. Philosophers of science begin to debate what natural even means in a universe that appears capable of such self-organization. Meanwhile, the public listens to the translated tones, unaware that what they hear may be the first sound of light shaped by geometry itself. And through all this, 3I Atlas continues its motion, serene and indifferent. It does not know it has become a mirror for consciousness. It does not know it has united thousands of minds across the planet in wonder and speculation. It simply moves, following its path, an object from another star weaving through our small corner of the cosmos. The days following the alignment are filled with analysis. Data streams from satellites reveal that the oscillations persist even after the geometry shifts. The frequencies evolve, becoming more complex, as if responding to solar variations. No artificial origin can explain it. It is an emergent resonance, the kind that arises when dynamic systems briefly synchronize before falling back into entropy. The universe, in a sense, had sung, and now it was fading. And yet, the echo remains. It lives in recordings, in spectrograms, in the hearts of those who listened. For many, it becomes a symbol of unity, of fragility, of beauty born from physics. Teachers play it in classrooms, musicians weave it into compositions, scientists replay it during long nights at their instruments. The sound becomes a thread connecting disciplines, a shared reminder that even equations can evoke awe. But for a few researchers, the data suggests something deeper. When they analyze the timing of the oscillations, they find correlations not just in frequency, but in phase. The pattern seems to anticipate solar changes by a fraction of a second, a tiny but measurable lead, as if the comet's plasma were responding to variations before they fully reach it. It is impossible according to our current models. Light and particles cannot communicate faster than the forces that drive them. And yet, the data is there, stubbornly precise. Some propose that the explanation lies in quantum coherence, the idea that, under certain conditions, particles separated by great distances can behave as if connected by invisible threads of information. Normally, such effects collapse long before they can influence macroscopic systems. But perhaps, under the delicate balance of the alignment, the comet's field acted as a temporary bridge, a conductor of correlation. If that were true, it would mean that the universe can briefly organize itself into states of awareness like unity, not consciousness, but coherence. A fleeting moment where cause and effect blur, and everything moves together, like the synchronized beat of a heart. It is speculation, of course, but it is speculation that stirs something ancient in those who ponder it. The thought that the cosmos, even for a moment, could act as one that within its vast machinery, there might be intervals of harmony, is enough to make even the most rational mind pause. And so, the story of the comet begins to evolve from observation into reflection. Scientists continue their measurements, but poets, philosophers, and theologians begin to ask their own questions. If the universe can harmonize, what does that mean for us, the beings who notice it? Are we merely observers of order, or participants in it? Perhaps, in listening to that faint cosmic song, we were not hearing something external at all, but something familiar, the echo of the same pattern that shapes thought, emotion, and life itself. Because deep down, we too are harmonies. Our hearts beat in rhythm with the planet's electromagnetic field. Our brains pulse in frequencies mirrored by the vibrations of stars. Maybe the comet's song was not a message from beyond, but a reminder from within that we belong to this great, unfolding music, that consciousness and cosmos are not separate instruments, but notes in the same eternal composition. The machines continue to listen long after the alignment passes. The frequencies fade into background noise. The comet drifts farther from the sun, its light growing faint. But the idea it awakened remains alive, that resonance, not isolation, may be the truest nature of reality. And as the world turns its eyes back to ordinary concerns, somewhere in a quiet laboratory, a scientist sits before a spectrogram and notices something faint but undeniable. The signal, though weaker, is still there, not from the comet now, but from somewhere else, somewhere deeper in the fabric of space. A new pattern, familiar yet distinct. Another voice, perhaps, waiting to be heard.